We have Veronika Kolesnikova. She's going to be talking about machine learning for .NET developers. Veronika is based in the Boston area. She's a passionate backend web developer, and she's worked with Microsoft technologies like C#, .NET, and Azure. She's also a public speaker, hackathon volunteer, and ML and AR enthusiast. She holds a master's degree in IT, and in her free time, she likes dancing, traveling, and practicing aerial yoga. Wow, that sounds very impressive. So with that, I will turn it over to Veronika.
Thank you, Sam. Well, hello, everyone. I hope you can see me, you can hear me. If you have any questions, definitely post them or unmute yourself and let me know. I'll be happy to answer them. So today we'll be talking about machine learning for .NET developers. If you are a .NET developer right now, or you are interested in .NET using C#, F#, or just starting out, and you're also interested in machine learning, then that session is for you. I'm gonna provide an overview and that introductory level of machine learning for developers, so you don't have to have any specific background in machine learning or data science in order to understand and go through the content. But if you have questions, again, feel free to stop me at any time. And actually, yeah, I forgot to mention that that is my Twitter handle. I am trying to be active there, so that's the best way to reach out and ask questions if you have them later. You can also find me on LinkedIn or through email. I also have my blog, so definitely reach out and ask questions later if you have them. But let's move forward. Just a couple of words about me. I know Sam did a really good job introducing me, but I just want to reiterate it again. My name is Veronika Kolesnikova. I'm twice Microsoft MVP in AI. I have a master's degree in information technology. I started my career as a quality assurance engineer, but then I moved to development, and now I have more than 7, I stopped counting at some point, more than 7 years of development experience. Mostly I used to work with Microsoft technologies like C#, .NET, Xamarin. I am really passionate about machine learning, but recently I also included Node.js, Java, and React to my portfolio. And as I mentioned, my hobbies are dancing, traveling, and aerial yoga. I think first two are kind of on pause right now, but hopefully I'll go back to all that fun stuff. So let's start with a general overview of artificial intelligence and machine learning. I know there are some confusions going on, how artificial intelligence is related to machine learning. Are they the same? Are they completely different? I know lots of people are using those terms interchangeably. In some cases, that's okay, but in order to actually understand the whole concept of artificial intelligence and the concept of machine learning, it's useful to actually know what's going on and how they're different. So I'm going to start with artificial intelligence, and in general, it is something that we as humans are good at, but machines are not. So we as data scientists and developers are actually trying to mimic human logic using if-then rules, using decision trees, and other techniques to mimic human logic in machines. Next one here is machine learning, and machine learning is a subset of artificial intelligence. In general, it's a combination of statistics and logic. So when you combine those two, and at the same time you have quite some amount of data, you can train your machines not only to mimic human logic and maybe human behavior, and sometimes, but also learn and improve tasks with experience. And then the third part here is deep learning. And deep learning is a subset of machine learning. So when you have a lot of data, you are trying to organize it and use it in the most efficient way. So you are creating multi-layered neural networks. You are actually using that huge amount of data to perform more complex tasks like image recognition and speech recognition. And we were talking with Sam just before that session about cognitive services. So cognitive services, those are definitely based on the deep learning techniques. The thing that I'm going to talk about today is ML.NET. I can already mention that. It can be deep learning precisely or machine learning in general, but it depends how you use it since it's more customizable tool. So I know that Brian, that had a session right before me, was talking about data. I caught like half of his session. So he actually covered it really well, but I'm gonna reiterate some little things here and there. The main thing in machine learning is data. And you need to understand that machine learning is not just some kind of magic tool that you just grab all the data that you have, no matter what, drop it there, and then you'll get something beautiful out of it. No, machine learning is garbage in, garbage out. So you need to make sure that your data is accurate, it doesn't have any bias, it's correct, and the better is your data organized, the better model you will get in the end. There's so many different ways how you can prepare your data, and here I listed just a couple of them. You can filter your data. So all the stuff that you don't need in your model, you can filter out because it will just clog your model with redundant and absolutely useless information. You can replace missing values if your data set is lacking some important values that you might need for your model to be trained. Then you need to replace them or somehow actually make sure that you just don't have those gaps in your data. And then you can use normalizers, and there are several of them. I mentioned just a couple here, like min-max normalization. You can use binding. You can remove default stop words like a, is, them, and so on. And all those things, the cleaning data, you can do also using some of ML.NET tools. The documentation is just great. That's why I don't want to go into details how you can prepare your data using ML.NET libraries. But if you're interested in that, definitely check it out. And also, Brian mentioned about responsible AI, about the potential bias in your data. You definitely don't want any kind of bias or any kind of misconceptions in your data. And Microsoft has amazing documentation. I provided a quick overview in my blog, so if you go and check it out, you'll see just a quick overview of responsible AI concept from Microsoft. They have guidelines and tools for you to actually use and make sure that your data is not biased and then your model is going to be awesome and be really responsible, especially, if you're using it in mission critical applications, then your model should be the best. And, I usually provide that example, and I know that other people around the world provided example when Microsoft created a bot called Tay and just let it out on Twitter to learn from different tweets. And I think they had to remove it within just several hours. It was definitely less than a day because the bot was out of control. It learned all that random information and became really racist, really aggressive. So that was a mistake from Microsoft's part, but it was a really, really good learning experience for all of us. So we know how important is the data. So now let's move forward, and finally we reached ML.net. I already mentioned it. That's the main point of my session today. ML.net is for us .NET developers who are using C# or F#, and would like to include machine learning, but for me personally, how I got to ML.net, I am really interested in machine learning. I started with cognitive services, and then I wanted to use something more custom, something that I can develop my custom models with. But at that time, I just didn't have enough time to learn Python or TensorFlow. And I was so happy that I found ML.net, and I didn't need to learn a completely new language quickly. So ML.net allows you to train, build, and ship custom machine learning models for different scenarios. And here you can see I just pointed out a couple of scenarios like sentiment analysis, product recommendation, object detection, and forecasting of any kind. ML.net now is becoming like a big community. It is open source. Here I provided a link to GitHub. You can check it out. They have links to documentation. They have lots of different samples that community provided, and also Microsoft provided some sample code there in the repo. So definitely check it out. They also post some updates right there. You can read some news. You can see what's going on. It is really, really useful. And also there is another tool that is providing that DevOps layer for machine learning. That is getting really big because machine learning tools, they are still software, and you do want to use DevOps, and they call it MLOps. So definitely check it out. They have so many awesome tools and scenarios that you can use there. So let's move forward and go a little deeper into ML.net and how you're building your model. So I took that beautiful picture, that beautiful schema, right from Microsoft Docs. And that one is actually, this one is showing how you build the model using ML.net and then how you use it after. On the top there, you can see that you are collecting and loading data into iDataView. You can prepare it, as I mentioned before, with some of ML.net tools. And then you are creating a pipeline using append method. And you are, when you use that append method, you are creating an estimator. Then you are training your model by using fit. So here I'm just providing you main methods of that ML.NET and what you need to pay attention to. So when you train your model using fit, you are creating I transformer, and then you are evaluating that I transformer interface and see if it works as you desire, if your model is actually accurate enough. Because for some projects you want to have more accuracy, but for other projects you can actually have less accuracy. It depends on what kind of project you have. For medical or mission critical projects, you definitely want to have higher quality model, not just quality, so it predicts better results. But if your model is not perfect, and I'm not going to tell you that it will be perfect at some point. I don't think there's a perfection. We're all software engineers, so we know there's always room for growth. But when it's reaching that point when you're satisfied with it, you're evaluated, and you either, if you're satisfied, then you save the model. If you are not satisfied, then there are so many different options how you can improve your model. And one of them is to add additional data and then retrain it again and then do it all over again. That's why we have that circle here. But when your model is all set, you save in the model and then you can use it. You are loading the model. So actually going back there, when you save it in the model, usually it's in zip file, so you can move it around. You can use it with, for example, Azure functions. You can use it with web apps. You can just use it wherever you want. And then when you are loading that model, again, using ML.NET, you are getting that I transformer, which you can use to actually predict. So create prediction engine .predict you need to use for predicting your label, for example, if you're using text data. So now I want to move to AutoML and talk about AutoML in general and ML.NET Model Builder more specifically. AutoML is a concept that is not directly related to ML.NET. It's not specific to it. AutoML is a general concept. I know that Google has some tools, Microsoft has tools that are not ML.NET related, but AutoML just saves you lots of time and lots of pain if you are working with machine learning models. Is the hardest part, I think, the hardest part is to actually choose the right algorithm for your data so your model can be the most efficient. And it is tricky, especially if you don't have a lot of experience with machine learning, if you're not a professional data scientist, then it might take lots of time, lots of learning. That is definitely not an easy thing to do. AutoML here covers the complete pipeline from raw data sets to the deployable machine learning model. Using ML.NET Model Builder, which is pretty much is based on that AutoML. It is utilizing AutoML functionality to create model based on the data you provided. And there are two options how to use ML.NET Model Builder. First is UI in Visual Studio, and the second is in CLI. I'm a visual person. I like all those shiny buttons. I like Visual Studio for those shiny buttons. That's why I prefer UI in Visual Studio, and that will be part of my demo. But if you're more of a CLI person, you like command line, definitely check the documentation. They have detailed examples how you can start using ML.NET Model Builder right from your CLI. And then the Model Builder supports not all the scenarios that ML.NET supports, but I think the main ones are supported there, like text classification, value prediction, image classification, recommendation, and object detection. They also support limited scenarios like anomaly detection, forecasting, and clustering. They again have good examples right in Visual Studio. So when I show you the screen, you'll see that there are lots of different options there for you to try it and to learn more about all those scenarios. Before we move to the demo, I wanted to mention that there is a tricky part. I mentioned that you can use the model that you created with Azure Functions and web apps. You can also use with other different applications like console applications, web applications. But the tricky part is that ML.NET doesn't support ARM. And so for some IoT solutions and mobile solutions, Azure Functions or web apps will be that middleman that can connect your mobile application with your ML.NET model. Otherwise, they can't be connected directly, unfortunately, and you need to remember that. So hopefully it will be resolved with .NET 6, but I can't promise you anything since I'm not working on that. So keep your eyes open on .NET 6 and on ML.NET to learn more about that. And now let's move to the demo. If you have any questions while I am opening my Visual Studio, definitely let me know. I hope you can see my screen. So I will make it a little bigger here, but there is not much going on actually. Oh, I need to move that thing away. Okay, so there's not much going on here. It's just out of the box console application. It doesn't have to be a console application, and it can be whatever you want. It even can be an IoT application or a mobile solution. But the tricky part, as I mentioned before, you won't be able to connect, to call your ML.NET model directly from your mobile application. So you'll need that middle layer. But that is the console application here. I am running Visual Studio 2019. So out of the box, you are getting that ML.NET model builder here. I don't think I needed to set up anything specific. It was just working out of the box, but there might be some settings. I know that for some people it's disabled by default, and you just need to go to settings and enable it, but it's installed with your Visual Studio, so you don't need to worry about that. Okay, so here, empty console application. I know I mentioned it like 5 times already, and I know you got me. Right click here, and you have that add machine learning. That looks pretty. You choose that machine learning, and then you see ML.NET Model Builder. So here it says ML.NET Model Builder. You see all those scenarios, text classification, value prediction, object detection, all of those scenarios that I mentioned, and also the limited scenarios. Here you can see examples, so you can click there and actually learn more about those limited scenarios and what you can do with those scenarios right from your Visual Studio. And also those little labels here, local ML or Azure ML and local ML. So I think that one is, the image classification is fun because you can choose Azure ML or local ML. If it's strictly Azure ML, let's try that. You can see that that one is in preview, and you need to set up your workspace. So you need to have the workspace connected to Azure ML. It's pretty straightforward. It will guide you through the whole process. So you basically selecting your Azure subscription and then machine learning workspace that you created inside your Azure portal, and then the compute name that you created inside that Azure ML. And if you are really interested in machine learning, then Azure ML is the tool that you want to check. It's like the whole portal. You can do lots of crazy machine learning things there. So I'm going back to scenarios because I'm not going to connect to Azure ML, although it's really cool, but you can explore it later on your own. I'm gonna go with like the main, the pretty straightforward and basic scenario of text classification, and it supports only local ML. So let's choose that one. It shows you all the crazy information about my computer, so you can see it is okay. It is okay. It can handle some machine learning there. So next step, you choose your data. It can be either file of those formats, or you can connect to your local SQL server right from here. I am gonna choose file. So let me browse, hopefully nothing crazy here. And that one is a pretty standard data set from Wikipedia. With just annotations, and that's a typical scenario when you have text of the comment and you're figuring out if it's toxic or not toxic. Actually, that one is too big. You can see it's 40,000 rows. Will probably take us quite some time to do that. So let's choose that one to 50 line data. So that is just for the demo purposes. I chose the smaller data set, but if you are working on real application, the more data you have, the better. For some scenarios, you don't have to have too much, but it's always better to have more than less. And also, it's a good technique when you get your data set, you clean it up, and then you divide it into two. So one you use for training, and then the second part we're using for testing. Okay, so here, column to predict label, that's sentiment here. It marks it as label, and so we're gonna predict the sentiment. If it's, I think if it's one, it's toxic. And if it's 0, it's not toxic. Okay, so and you can see the data preview, so you understand what kind of data you have, but definitely it's really important to understand your data before you start using those tools. Okay, next up, time to train in seconds. It kind of offers you the amount of time that you need in order to train a model to go through several scenarios. You can definitely change it. This field is editable. And also they have a good article here, how long should I train for, so you can read to understand more. It offers 10 seconds. That's perfect for us because we don't have a lot of time today. And
I got a question for you about that.
Sorry?
I said I got a question for you about that. Are there other ways to train that, such as one of the things that I've done in the past is like you might train until you either hit a certain number of epochs or until you hit a certain accuracy. So like one of the things I think would be kind of hard is like depending on the problem I'm trying to create, how would I know what a good training time would be? Is it guess and check and then change it?
Yeah, so you can read more in the article. I usually just agree with their suggestion, and if it's not enough, then I add more time and train it again.
Okay, so the time that it gives you is based upon the data that you specified in earlier in the previous step?
Yes, yes.
Oh, okay.
Yeah. In that step, it actually goes through several algorithms and tries them and see if they match with your data and which algorithm is the best for your kind of data to create the most accurate model.
Does it also make use of GPUs? Like, let's say, for example, I'm trying to detect like images or something like that, where they might be really CPU intensive. Is there a way to specify, or does it automatically detect that you have a GPU and use that for training?
Yeah, so when you do it on your local, it automatically detects, and there is not much that you can do. If you know that it's really heavy process, you saw that some scenarios they had two options, like you can use Azure ML and you can use your local capabilities. So Azure ML will be definitely more powerful.
Okay, I got you.
Okay, doesn't want to train. As always, when you're running a live demo, it doesn't want to work. But I think just the problem is with the data set because it's so small. It just, yeah. So the accuracy is just 72.5%. That is not perfect, but what can you say? It's like only so many data rows available there. One model explored total, and you can see the output right here. It checked this model, and that's the accuracy and duration, just one iteration. So I want to move forward. That's definitely not enough time. And going back to Brian's question, you can see that it wasn't enough time, that we don't have enough data, because it went just through that one algorithm. It tried it, it took 10 seconds, and then you see that you probably need more time in order to go through several algorithms and try them all and select the best one. Okay, next step. So here you can try your model. So that sentiment text, it just grabs from your data set. But as I mentioned before, the better approach will be to split your data set into two, one for testing and one for training. I didn't do it, so I can just either replace that sentiment text with my own text that I come up with, or just do whatever it offers me to do. So it predicts that that comment is toxic, so that is pretty accurate, 99%. That is pretty good for that basic application. So next step, what can we do? We need to consume that model. And that's also a great part because that was a mistake because I tried it before just to make sure that it works. But when you add to your solution, it automatically adds two projects to your solution. One is your actual model, and it's marked as model. And the second one is console app for testing. So you can test your model right here. When you write in real world application, you probably run that console app once just to make sure that it works and that your model is connected, it's working correctly, it's predicting, and then you can delete it because it will just clog your solution. Okay, so here we have that model, ML model.zip. That's your actual model. You can move it around. You can use other tools to actually connect to your model. And then another cool thing, which is not directly related to the model builder, but related to ML.NET, is that ML.NET supports models created with TensorFlow and Onyx. So if you already have your models created with those other tools, then you can still use ML.NET to work with them. Okay, so what we have here, the model, then we have model input here. Let me minimize that. You can see we have sentiment and sentiment text. Output, prediction label. So we are predicting the sentiment, and also we can get a score. So we see how confident the model is about that prediction. Okay, let's go here, consume model. Here you can see just, it also has some links so you can read that documentation there. But here it helps you to consume your model, and that ML context is the main thing you need to create in order to consume the model and predict. I think you remember I mentioned that I transformer and then create prediction engine using the model input and output and passing your model there. And that's your engine. Okay, let's go here and see what's going on. So here, just hard coded the text. You can change it to whatever you want. And then it will provide the output. You can see it is not hard coded. It actually grabs your text and then predicts and includes prediction into the result. So let's run that one and see how it all works. And let me make it startup project so we can run it. So, okay, so it passed the sentiment text that we saw there. The predicted sentiment value is 1, so that's rude or offensive comment. And then the predicted sentiment scores 99% that it is toxic, and less than 1% is that it's not toxic. That's what we have here for testing. In order to use that model in your application, what you need is to go to NuGet. And let me show you. Take some time. You can type ml.net. It's not actual code ml.net, but sometimes you're like, oh, there's so many different names here and there, and it's hard to remember what goes where. So if you type ml.net, you will see that Microsoft.ml, and that's actually ml.net library that you need to have in your application in order to interact with the model that you created. We are not going to use that since we already tried it. We have the model builder information here, so we can see what model builder actually did. You don't have to use model builder in order to create your model. You can write all that code from scratch. You can choose the best algorithm yourself. That is always an option. Or you can use CLI tool, as I mentioned before. So I think that's it. That's what I wanted to cover today. If you have any questions, definitely let me know. I'm gonna open the slide so you can see my Twitter handle. Yeah. Okay, so that's my Twitter handle, Veronika_dev1. Feel free to reach out if you have questions later or you need any help. If you decide to find me on LinkedIn, definitely write a message, who you are and how you know me and why you're trying to reach out. I'm not trying to be weird, but I just want to know who is reaching out so I can better help people. And I think that's it. I don't see any questions. Feel free to unmute yourself if you have any, but if not, I think I'm all set.
Excellent. Thank you very much, Veronika.
Thank you.